What's going on, guys? In this video we are going to look at homogeneous second order differential equations. The second order differential equation usually come in this pattern: a y double prime plus b y prime plus c y, and we know this is the second order by looking at this derivative. If it's second derivative, it's second order, okay? And we will have second derivative, first derivative, and then no derivative, that's equal to 0. And if we have equation like this, first thing is we convert this one into this pattern. We put a r square. A is the coefficient in front of this y double prime, second derivative. So we put it a in front of this one, and when it's second order, we put r square instead of that, right? Instead of y double prime, we put r square, and instead of y prime, we put r, and since we don't have any derivative, we just keep it as 1, and the coefficient will remain here, okay? Now let's look at some examples to see how to solve this one. So here we have one example: y double prime plus y prime minus 6y is equal to 0. So the first thing is we have to convert into this pattern: ar square plus br plus c is equal to 0. If we do that, this is going to become r square plus r minus 6 is equal to 0. Now we have to factor this one, and if you factor this one, you will get r plus 3, and then r minus 2 is equal to 0, and therefore we will have r is equal to negative 3, and also we will have r is equal to 2. Here we have distinct real roots. So when we have distinct real root, the general solution for the differential equation will be in this pattern: y is equal to c1 e power, the first r value will go into the power, so that's going to be negative 3 multiplied by x, and c2 e power, and this one go to the top, multiply the x. Okay, so this is going to be the general solution for this differential equation. And if they give the initial value, you can find out c1, c2, and so give the particular solution. Now let's look at another problem. Here we have y double prime minus 8y prime plus 16y. Same thing, first we have to convert this one into r square, that pattern. So this is going to be r square minus 8r plus 16 is equal to 0. The next thing is we have to factor this one. If you factor this one, you will get r minus 4, that's equal to 0. So r will be equal to 4. Here we have equal real roots. There are three kind of real roots you can have. You can have distinct real root, you can have equal real root, and also you can have the complex numbers. So based on that, the final solution for the differential equation will be differs each time. Now for this pattern, like when we have equal real roots, this is equal. The pattern for the general solution of the differential equation will be like this: y c1 e power, we put this one in the power, 4x plus c2, and here what we do, instead of previously we didn't have x in front, we had to put x here and e power 4x. Okay, that's the only difference. Previously, if you look at this one, we just put the r in the power, that's it, right? But for this one, here we have multiply this one with x, and that's the only difference, and that's it. I hope this helps. Thanks for watching, and don't forget to subscribe. And if you are trying to learn differential equation, there are a bunch of videos on my playlist. I hope you guys watch that too. See you next time.